Hello class, so in this video we're going to be talking about function growth rates, what they are, how they apply, and what we can do with them. Alright, so let's take a quick look at these two, f of x equals x and f of x equals x squared. So remember that the rate of growth or rate of change of a function is determined by either the slope or slope of the tangent line. So for the line, you can see that that's just going to be the same thing no matter what. But for the parabola, you see if we took tangent lines, we can see something like that. And then at another step, we see this. And at another step, we see this. So we see that the growth rate is changing and it's getting greater and greater, right? So let's look at what that can tell us. Let's look at another example and work with that. Alright, so for this, we have x plus 2 and x squared plus 2x minus 5. So again, another line and parabola. Line still has a constant slope, but if we look at points of tangent lines, let's just say that's going to be a tangent, that's going to be a tangent, and things like that. I'm not drawing directly on it just so you can see it, the tangent line slope a little bit more easily. But as you can see, the thing just keeps increasing and it does that really quickly. So still here we can see that the one with x is still growing slower than the one with x squared. So these are polynomials, and something the mathematicians talk about polynomials with is called the dominant term. So that's essentially just the term that has the highest power. And it's actually not necessarily just with polynomials, but with a lot of other functions you can see similar ideas. When you have things added together, dominant term just refers to the biggest piece, I guess you can call it. So let's look at this and try to determine what are the dominant terms. So as you can see from the first one, we have 2 plus 4x plus 8x squared plus 6x cubed. So what has the highest power? We see this. So yeah, that one's gonna actually be the dominant term in this case. Alright, let's look at the next one. Here we have x to the 7th plus 2x cubed minus 1. X to the 7th has the highest power. It determines a lot of what goes on, so that is a dominant term. Now we have that same polynomial with e to the x added to it. So which one is greater, e to the x or x to the 7th? Well, actually e to the x. So exponentials look like this, right? The thing about exponentials is they actually grow with a really, really fast growth rate as compared to polynomials. So actually, if I were to compare it to scale with a polynomial, this is probably closer. This is what the exponential would look like, and a polynomial would probably look something more like this, just relative to the exponential. Okay, so let's look at some of the other things we have. So y equals 1 plus 2x plus 2 to the x minus x factorial. Okay, so now we have an exponential and we have a factorial there. So question is, which one is greater? So if we look at, let's just say, for instance, 2 times 2 times 2. That's x cubed, right? Or 2 to the 3rd power, 2 cubed. That's 8. And 3 factorial. That's 6. Okay, well, what about if we did 2 to the 4th? That would be 16. 4 factorial, though, is 24. And notice that if you actually were to get 5 factorial, this is 120. If you get 2 to the 5th, that's 32. So it's pretty clear then that what's happening is the growth rate for the factorial is a lot bigger than that of the exponential. So in this case, that's the dominant term. Alright, and then here, again, we can look at, since we just have x to a power, we can just look at what's the highest power. Alright, so why is this significant is the question. So we can conclude that polynomial growth is less than exponential and is less than factorial, as we can see over here, just summarizing that. And it helps specifically with limits to infinity and the concept of end behavior. So for rational functions, so remember that just means a function that is a polynomial over a polynomial. So something like x squared plus 4 over x cubed minus 2x plus 3. That's a rational function. Or even just like 1 over x, that's a rational function as well. We can analyze what happens toward the infinities with these things. So looking as x approaches infinity, what can actually happen is you can either have the quantity itself approach infinity, 0, or some number. And also, if it approaches number, this is a horizontal asymptote. Alright, let's practice that a bit and determine if these each approach infinity, 0, or a number. So let's compare the growth rates. So on top, we have that and that as the dominant terms. We essentially have x squared over 2x squared. So they grow at the same rate, so this is pretty much just going to approach some number. How about here? We have those two. Are they the same type of growth? Yes. They're both factorials. So we essentially see that toward the infinities, this is going to approach a number. Alright, now let's look over here. Dominant term is e to the x. Dominant term is x squared. So let's just compare those two. So e to the x is growing a lot quicker than x squared is, so this is actually going to tend toward infinity. Because essentially if the top grows quicker than the bottom, it makes sense that the quantity is just going to keep getting bigger. So if you want to, you can actually just start plugging in numbers like e to the 10 over 10 squared, and then try e to 1,000 over 1,000 squared. You'll see the e is growing significantly quicker, and you're going to get toward infinity. So on the other hand, so now I just made the reciprocal of that one with x squared over e to the x. This is going to approach, in a way you can think of like the reciprocal of infinity. This is going to approach 0. Reason for that is the growth rate on the bottom is a lot quicker now. So if you were to flip these, you would notice actually that the growth rate in the bottom being bigger will make it so that your quantity starts to approach 0 more and more. Okay, so now let's look at this one then. 1 over x squared. Dominant term, well, there's only one term. We have 1 and x squared. So what's actually happening here? If you imagine you have 1 over some big number, what's going to happen is you get 1 over... So you can imagine it kind of this way. Let's say you bought one lottery ticket, and then there's some number of people, some number of tickets that are bought, and your chance of winning is 1 over whatever that is, right? So 2 people bought tickets, including you, then your chances are 1 and 2. So what happens as the number gets bigger? As it gets bigger, your chances of winning get closer and closer to 0. Alright, so as you can see, function growth rates do tell us things about infinities. It tells us basically whether the function is going to converge or not, and whether it'll be to 0, to some number, or to infinity. In mathematics, a lot of differences like that will happen. Alright, so that's the end of this video. Thank you for watching, and see you in the next video.